given that F is equal to MA and V is equal to U plus AT, so that I is equal to M times V minus U, where I is equal to the impulse. These two equations, they are known as equations of motion. Take down proof. For us to easily show this, we are going to start by making A the subject of formula in the two given equations of motion. Take the first one, F equal to MA, then dividing both sides by M, F divided by M will be equal to MA divided by M. At the right hand side, mass will strike off mass, then this will give us the acceleration to be equal to force divided by the mass. We call this one equation I. We take now the second equation. We have V equal to U plus AT. Then, making A the subject of formula, we are going to start by transferring U to the left, which becomes negative. This will give us V minus U to be equal to AT. Then, dividing both sides by T, V minus U divided by T is equal to AT divided by T. This will give us at the right hand side T will strike off T. A will simply be equal to V minus U on T. We call this one equation 2I. You will see that we can equate these two equations since their left hand sides are the same, AA. So we can express this as F on M is equal to A, which is simply equal to V minus U on T. Then we can write this as F over M is equal to V minus U on T. This will imply that cross multiplying, this will give us Ft, that means force times time, to be equal to mass times the difference of initial and final velocity, V minus U, where V is the final velocity, U is the initial velocity. Then force times time gives us the impulse to be equal to the mass times the final velocity minus the initial velocity, which is what we are to show. We are done with the solution of this question. If in case you have any doubts, feel free to drop your questions at the comment section. Please like the video, share, and subscribe to this channel. Thank you very much for watching.